Hi, Noah. So the point of these is to try and simplify them and then figure out which values would be restricted in the domain, which means they like seem like they would work, but they wouldn't because you canceled something out that would have made a zero in the denominator, right? Like anything divided by zero means like it doesn't work. So we're just trying to figure out what would make zeros in the denominator. To do that, we have to factor. So you take, like, this can't be factored, right? It's already done. So is that. So we're just going to focus on the things that can be factored. And this is like back to Algebra 1. So you've got to remember how to factor stuff. So this one here is a difference of squares. You might have learned it using like a box and diamond. I don't think I taught it to you that way. I don't think I had you for algebra. But however you would factor it, you would end up with x plus 9 and x minus 9 for that one. And then for this guy up here, you would do, we need two numbers that multiply to 45 and combine to -4. So 45 would probably be a 5 and a 9, and those could subtract. So maybe an x minus 9 and an x plus 5. I'm making the 9 negative because it's a -4. So I know that when they combine, the negative one has to be bigger. So I'm just going to rewrite it with those things. So 6x is at the top, x plus 9, x minus 9, and then x minus 9, x plus 5 over 2. So I just rewrote that original equation with the factoring. So now, really, this is just one big problem, right? Because when we multiply fractions, a over b times c over d, ooh, it's not a d, that's barely an a. So when we multiply fractions, that's just ac over bd, right? Like 1/2 times 2/3 is 2/6. You just multiply top and bottom. So I'm going to do the same thing here. I'm making this one big fraction. So 6x, x minus 9, x plus 5 over x plus 9, x minus 9, and then times 2. And then from here, I can cancel. So I can make ones. Anything that's the same factor, top and bottom, I can eliminate. So in this one, there's only one thing I can do. I can do the x minus 9 and the x minus 9, like that. And so I eliminate, that's gone. But when I do that, when I eliminate it, I need to have noted that if I had put a 9 down here in that x spot, it would have made it 0, right? Because if I did 9 minus 9, that would have made a 0 there. And then 0 times, doesn't matter what this is, doesn't matter what that is, 0 times anything makes it 0. And so the whole thing would be void. The whole thing would just like collapse into a pit of dust. It would be gone. So that means that we have to say that x cannot equal 9. That is the domain restriction. Because when I cancel, I'm going to cancel that out now, but when I do so, I need to remember that x cannot equal 9. All right, so then I cancel it. So 6x, and then the top is just x plus 5. The bottom is still, the x plus 9 is still there. That one didn't get canceled, and the 2 didn't get canceled. I'm almost done. I also, though, noticed that there's a 6 and a 2, and since 6 halves is the same as 3, I could just simplify those. So that would leave me for a final answer with 3x, x plus 5 over x plus 9. I don't know if your teacher wants you to then distribute back out the 3x and the 3x times x and the 3x times 5. But either way, that's like a final answer with saying that the domain x cannot equal 9. Now, the x also can't equal -9. I don't know if they're going to want you to say that or not, because that's like here, right? Like x can't equal -9 because -9 plus 9 would give you 0. and that would like restrict that. So sometimes teachers want you to call that out explicitly. Sometimes you don't have to say it because it hasn't been canceled as part of the process, and like you can still tell by looking at it. I don't know if that makes sense or not. So if I were teaching this, I would say that the domain restriction is that x cannot equal 9, but you might also be required to say that x cannot equal -9, because that's the one that would make this one not work too, even though it's still there in the problem. I hope that helped. I just realized there's like a whole bunch of different types of problems in here. This is way more than like a couple YouTube videos. This is like an entire unit. I can't summarize an entire unit. If you're adding or subtracting, you need to make common denominators. So 5 and 15 are not the same number, so you'll have to multiply the first one by 3/3, because anything over itself is 1. So you can just like as long as you do the top and bottom the same, you're good. So that gives me 3 times 2x and 3 times 7, so 6x plus 21 over 15 minus x minus 11 over 15. And so now that these are the same denominator, just like how if you had 7/5 minus 3/5 would equal 4/5, we can just leave the denominator the same and subtract the numerator. So that'll give me 6x plus 21 minus, and then I'm subtracting all of this, so I kind of have to think about it like it's in parentheses. So minus x minus 11 over 15, right? Because I just get to subtract the top and leave the bottom the same. I do not subtract those numbers, then you'll get a 0. That would not be the way math works. And then you do this, so you get 5x and then plus 10. Oh, no, sorry. You're distributing the negative. So that's like minus x and then plus 11. So that would be plus 32 over 15. 5 and 32 don't have any common factors. You can't factor anything out. So you're done. And on this type, there's no domain restrictions because there's no x's in the denominator. The only time you have domain restrictions is when there's an x. Like, domain restriction means 0 in the denominator of a fraction, right? You're trying to identify spots where that could happen, and it can't happen here. So no problems. On the ones where you have fractions like this, this is like the same like as that first one, except since you're dividing, you have to remember that when you do like 5 divided by 3/2 is the same as 5 times 2/3. You change it to a multiplication and then you flip. And then you would do the same thing we did in that first one where you would factor. In this case, like this is your main factoring job, right? You'd factor, you'd identify common factors that you could cancel, note anything that you're canceling what would have made it 0 in the denominator, that's your domain restriction, and then keep going from there. So I'll just do it. So I factored that. I'm just skipping steps, making that one big fraction, multiplication in there. That would eliminate n cannot equal -5 because that would have made it 0. And then I can cancel one of those, so n also can't equal 0 because that would have made it 0 there. I'm still left with an n there. So 2 over n plus 3 times n cannot equal -5. And like I said, I'm not sure if you're required to say that n cannot equal 0 or not, because that one's still like shown within the thing. I don't teach this actively, so you'll need to check with your teacher on that. Good luck.